On number 6, we are to compute the exact value of the function for the given value of x without using a calculator. So pretty simply we plug in -2, which this first step is really no effort at all. We're just going to replace x wherever we see it with -2. Well, this is where you need to remember your exponent rules. When we have a negative exponent, if the term with the negative exponent is in the denominator, the numerator, it gets moved to the denominator. And since our 3 is in the numerator, because of its negative exponent, it gets kicked to the denominator, and now the exponent on it is positive. So that would be your first step to take. So then this is 6 over 1 times 1 over 9, and then obviously we can cancel a factor of 3 out, which would give us 3 in the denominator, 2 in the numerator. 2 times 1 is 2, 1 times 3 is 3, and that's our final answer. Then on number 12, we are told to write the equation for the exponential function for the given table, and f of x we will leave for you to look at on number 11, I believe it is, but our table is the g of x column that we're looking at. Well, the first thing to think about if I'm writing an exponential function is I want to start with a b to the x, and a is always the number, the output, the y-coordinate, when our input is 0, so this gives me my a. So I already know that a is 12, so I replace a with 12, and then I can choose another point. My second favorite point is always the one with x equals 1, so I'm going to put 4 where the y was, and I'm going to put a 1 where the x was. Well, that's pretty cool because now we have to solve a linear equation. Pretty simple. Divide both sides by 12, so that tells us that b is 3, which is also known as b equals 1/3. I was getting ahead of myself. When we reduce 4/12, we get 1/3, but you should write it with a negative exponent. So that would be b equals 3 to the -1. So our final equation then is y equals 12 times 3 to the -x. And that is number 12. On number 14, we are given a graph of an exponential function, and we're to write the equation for g of x. So, sort of like the last one we did, remember that when you see where x is given to be 0, its y-coordinate is a. So we know from that that a is 2, and we know that we're going to use y equals ab to the x, which is the generic format of an exponential function. So we'll use the other point to replace x and y, and now we know that a is 2. So y is going to be 2 over e equals, and a is 2 from here, and then b we don't know, that's what we're solving for, and x is 1 from our point that we're using. And again, when we have the best situation where we have the points at 0 and 1, then this works out this way every time. So then you can think of this as multiplying each side by half or dividing by 2. But if we multiply by half, we get rid of the 2 on each side, and we're left with 1 over e equals b. And just like we did on the last one, we're going to rewrite this as b equals e to the -1, which gives us our final equation using everything we've learned here, that y equals 2 times e to the -x. That's all you have to do for that one.